type where the solution will not exist. So yeah, just a second. Suppose our question is this one. Minimize the objective function is z is equals to 3x plus 2y. Okay. And subject to constraints x plus y greater or equals to 8, 3x plus 5y is smaller or equals to 15, x bigger or equals to 0, and y also larger or equals to 0. Okay, please check no. What are you getting? Annapurna? Yes, what are you getting, Annapurna?
The corner points?
Corner points. Have you got the corner points?
Yes,
What are the corner points? Is it bounded or unbounded?
it's bounded.
Bounded. Okay, let's check it over here. So x plus y is bigger or equals to 8. When x is 0, y is 8. And when y is 0, x is 8. Solid line or dotted line, Annapurna?
Solid.
Solid line. Yes. Now, which part is the shaded region? This line is there, the left part or the right part?
Left.
Left. 0, 0, if I am substituting over here. Is it so? 0 is bigger than or equals to 8?
No.
So, right one, right? Right, Annapurna? That's how we check, right?
Yes.
And if we don't want to take 0, 0, then I was telling you so you can take any point on the y-axis or maybe any point on the x-axis. But in between, please don't take any point, okay? Because there is an inclination in the line. So this is the part which is representing our inequality, right, Annapurna?
Yes.
Okay, now the next one. It says that 3x plus 5y is smaller or equals to 15. When x is 0, what is y? When x is 0, what is y?
3.
And when y is 0, what is x?
5.
A solid line or a dotted line?
Solid.
Now, which part? The left one or the right one of this line?
Left.
Is there any common reason? Common shaded portion?
No.
No. Okay, till now we have solved question and we have found that yeah, common shaded portion exists. But from now, I mean, this type of questions, there exists such a scenario where the common shaded portion doesn't exist even. So what will be the common solution? How to minimize this z? Okay, how we'll be minimizing this z? How we'll be minimizing z? For minimizing z, at first these are just the condition. You understand, right, Annapurna? These inequalities are nothing but just the condition which has to be fulfilled. And then only we are checking which one is like which point is giving the minimum z, right?
Yes.
So if there is no like we are not reaching at a common part there where both the condition must be fulfilled, that means we can say that the common solution like minimum z it is not possible to find over here. We are not having the common shaded portion, and hence finding the minimum, for this objective function, finding the optimal solution is not possible, right?
Yes.
Okay, optimal solution means minimizing or maximizing, whatever it says, that is not possible, since there is no common shaded portion from both the inequality. Hence, solution doesn't exist. Are you struggling with finding the common reason, the bounded or the unbounded?
No.
Let me give you a few questions. Please check, because when we are plotting the line, till that, Annapurna, I can see you are very clear that, yeah, whether it will be dotted line, whether it will be solid line. But while checking whether it will be left or right, and what will it be bounded region or unbounded region, there you need practice. That also you are getting it, but you just need practice. Let me give you a few questions and let me check. Just a second.
Does bounded mean it exists till
Yeah.
infinity?
Are you saying bounded means extends to infinity?
Yes.
Bounded means, we were having bounded region previously, like this. That means it was bounded. This, it used to be bounded. This type of region, after taking both the inequality and after plotting them, we were getting this type of bounded region, right, Annapurna? I mean this one, right?
Yes.
Okay, this is called bounded region. Here, particularly, we cannot say anything about what will be the inequality. It depends. Whatever is the inequality, if the first line is representing that the shaded portion will be this side, and the second line is representing that the shaded portion will be above, then this is the common shaded portion, right, for both of them.
Yes.
Okay, basically we need to shade the portion. Since you have just started learning this concept, arrow can if arrow is creating confusion, then please shade it. Okay, I'm giving you one question, please shade the reason and then check it which one is the common shaded reason. Minimize z is equals to 3x plus 5y, such that x plus 3y greater or equals to 3, x plus y greater or equals to 2, and xy greater or equals to 0. Okay, please just draw the figure, check it whether we are going to get bounded region or we are going to get unbounded. This time, please go ahead and shade it, and then you'll be able to figure it out. Yes, Annapurna, are you getting a bounded region or unbounded region?
Bounded.
Okay, bounded you are getting. And what are the corner points? You are finding it or you got it?
3002.
Okay. So x plus 3y when x is 0. Let me try to open it. Yeah. When x is 0, y is 1, right?
Yes.
And when y is 0, x is 3. A solid line will be having, right, Annapurna?
Yes.
the shaded portion we have to check. So 0, 0, it is not satisfying, right?
Yes.
So basically this part is the shaded portion. Now I'm using different color. When x is 0, y is 2. And when y is 0, x is still 2,
2.
right?
Yes.
A solid line or a dotted line?
Solid.
Here also we will substitute 0, 0. Okay. Is it satisfying?
No.
So that means this part, is it a bounded region? Is it bounded, Annapurna?
No.
No, it is not bounded. Okay. The first line we have plotted, which is this one. Okay. It says to go up in that direction. Okay. Because 0, 0, it is not satisfying. The second line we have drawn, which is this one. Just a second. This one. And here also it says to go up. Okay. When we are doing so, still we are not getting any bounded region, right?
Yes.
So we can say the solution is like here the common reason is unbounded. Now we have to check whether will it be possible to find one and only one minimum or not. Okay. So the corner point, what are the corner point over here, Annapurna? Can you see
0, 3, and 2, 0.
this? Okay. This one is the corner point because the sky one is saying just go in this direction, and this pink one is also saying to go in this direction. So basically we can, since the pink one is up like above the green one, we can say this is the corner point, this is the corner point, and what else, Annapurna? 20 or 30?
2, 0.
30. Okay, these are the corner points. Okay, now we'll be checking. Please find our objective function z at corner point. Just a second. So we'll be finding z at 0 to, okay, at what is this point? We don't know the coordinate. We still have to find the coordinate over here. Right, Annapurna?
Yes.
Have you found? Please find it.
I'm getting a fraction.
You are getting? What exactly are you getting?
3 by 2 and 1 by 2.
Let me check. Method of elimination works over here. We can just do the subtraction. 3y minus y will be 2y and 3 minus 2 will be 1. So yes, y you are getting 1 by 2, right?
Yes,
And x is
3 by 2.
3 by 2. Yeah, we'll be getting the same. Okay. Yes. Let me check. Y is 1 by 2. So yeah, 2 minus 1 by 2. Yes. Yes, it is correct. So we'll be checking at these points. 3 by 2, 1 by 2, 3x plus 5y. Okay. 3x plus 5y. 3x plus 5y. Okay. 3x plus 5y. Please do the calculation and tell me.
10, 7, 9.
10, 7, 9. And what we have to find? Minimum z. Which one is the minimum one?
7.
7. But this, since we are having unbounded region, we cannot say this is the minimum value, right?
Yes.
Okay. So what extra steps we have to perform on Annapurna for unbounded case? Yes. We will be taking the z, okay, and we'll be saying that is smaller than whatever we are saying we have got the minimum value, right, Annapurna?
Yes.
Okay, so z is 3x plus 5y. That is smaller than this 7, and we will be plotting this inequality in the same coordinate plane. So we are having 3x plus 5y is smaller than 7. Okay, let's plot it. When x is 0, what is y? When x is 0, what is y, Annapurna?
7 by 5.
7 by 5 means, let's get an idea so that we can locate it properly. 1.4, right?
Yes.
And when y is 0, what is x?
7 by 3.
7 by 3 means what? In decimal?
2.3.
2 point something, okay, 2.3 or whatever. So let's locate it 2.3 comma 0 and 0 comma 1.4. 0 comma 1.4. Just a second. This was It was 1, right? It was 1 comma 0, right?
Yes.
Okay, so 1.4 somewhere on the like just up somewhere here. Okay, 1.4 and
It
the other
was
one.
0, 1.
Yeah, what? Okay, yeah, that was 0 comma 1, not 1 comma 0, since it's lying on y-axis. And the next one is 2.3 comma 0. So this is 2 comma 0. 2.3 must be here, right, Annapurna?
Yes.
Okay, let's try joining it with a straight line. The line has to be really straight, okay? Because here randomly if I will draw a line, no, maybe I will find that yeah, it is lying in the common region, or no, maybe it's not lying in the common region. So let me use a straight line. Let me check. No. Have you drawn the figure in your copy?
Yes.
Please join this two line, no, and tell me it seems like it is not lying in the this unbounded portion. You tell me, you confirm it. It's not lying, right, Annapurna?
No.
Okay, then this is the minimum value. Whatever we have found the minimum value, that is the one and only one. Okay, minimum value, which is like that is the minimum also and satisfying all the condition also. Okay, lying in the feasible reason also and is minimum also. Getting it?
Yes.
This is our solution. If it would have lied in the our feasible reason, we have made the dot. Okay, from that corner points we have located these three corner points we are having, and this one is the feasible reason. This one is the feasible reason. In this feasible reason, we are basically finding such a coordinate which is in this feasible reason and is giving minimum. A point which is in this feasible region and is giving minimum z, okay, that will be our optimal solution. So that point, our the like the steps which we have performed, that indicate that that point is 3 by 2 comma 1 by 2 7. Now to assure that yeah, this is the only one point in our feasible reason, we have plotted this inequality. Okay, whatever objective function you are having, that is smaller than 7. And dotted line you must draw. I have drawn a solid line. Dotted line we need to draw, and we need to check whether it is lying in the feasible reason or it is not lying. If it is lying in the feasible reason, that means there are so many points apart from this one, 7 by 3 by 2 and 1 by 2. Apart from 3 by 2 and 1 by 2, more points are there which will give the minimum. Okay, that time there will be so many solutions. One particular solution we are not able to find. Okay, and if it is lying outside of the feasible reason, just you can see this line is touching this point, 3 by 2 comma 1 by 2. It is touching, right? When you have joined it, it is touching this point, right?
Yes.
Okay, that means It is lying outside and there is only one point, 3 by 2 comma 1 by 2. This point is giving minimum z, that is 7. Clear, Annapurna?
Yes.
Okay, so this is unbounded scenario. Step by step, very carefully we have to perform the steps. Let me give you next question. First you identify what, whether it will be bounded or unbounded. Okay, that is the very like important step, to identify whether we'll be having bounded or unbounded. Max z we have to find, that is x plus y, subject to x minus y is smaller equals to minus 1, and minus x plus y smaller equals to 0. Again the first quadrant, that means xy greater or equals to 0. Check it, Annapurna. You just check it and tell me, are we going to get a bounded region or unbounded region? And from there, we'll be doing it together. Yes, Annapurna, are you getting bounded region or unbounded region? Are you getting feasible region? First thing is that we may get the feasible region. Now, if we are getting the feasible region, that can be bounded, that can be unbounded. If we are not getting the feasible reason, then the story will end. We will say the solution doesn't exist. Are you getting feasible reason, Annapurna?
No.
No. That means solution doesn't exist. Let me check. Today you can give the assessment as well. Okay. X is 0, Y is 1. Okay. So somewhere here, X is 0, Y is 1. When Y is 0, X is negative 1. When X is 0, Y is 0. Okay, when Y is 0, X is 0, for this type of point, we understand it will go touching the origin. That's why this is how we are getting the point. If you want, you can take out few more point by just making the table and taking some random X, or maybe taking some random Y and then finding X. Okay, right, Annapurna?
Yes.
Okay, so previously this was the line. Both are solid lines. Now we need to check which one is the shaded portion for the first one. For the first one, 0, 0 is smaller or equals to, so this part. 0 is smaller than 1 is not there, minus 1 is there. So other part, it is not satisfying, right, Annapurna?
Yes.
Okay, I thought it's 1. This one. And the other one, 0, 0, it is of
Yes.
course, okay, it is satisfying. But to check whether this part or that part, I told you, you take any point on the x-axis. Okay, you will get to know. So suppose I am taking a point on the x-axis, maybe 2 comma 0. Okay, maybe 2 comma 0. So if we'll be taking x as a 2, minus 2, and y as a 0, is it valid? Minus 2 is smaller or equals to 0. Is it so?
Yes.
Yes. So this part. And yes, there is no feasible reason. Okay, there is no feasible reason. Hence, we cannot find the solution.